Hello, boys and girls of St. Lucie Public Schools, aka fabulous 4th grade. I'm Miss Owens, the math coach at Longwood Elementary, and I am super excited to be able to work with you guys on Tuesdays and Thursdays. So thank you for tuning in to the MotIvation Station. In today's lesson, we are going to work on solving problems involving measurement. That's right, the magic word here is measurement. So go ahead and grab your reference sheet because you cannot solve problems involving measurement without your handy dandy tool. I will give you 5 seconds to go ahead and grab your reference sheet and something to write on and something to write with. Are you ready to go get your materials? Okay, 5 seconds. Here we go. 5, 4, hey, 3, 2, and 1, and 0. All right, thank you for being quick on your feet. If you hear a dog barking in the background, that's my dog. I need him to be quiet, but sometimes he likes to bark. Okay, so let's go ahead and take a look at the standard for this lesson. The standard is MD 1.2, and the standard reads, the student will be able to use the 4 operations, that's addition, subtraction, multiplication, and division, to solve word problems involving distances, intervals of time, and money, including problems involving simple fractions or decimals. The student will also be able to represent fractional quantities of distance and intervals of time using a linear model. Let me see you do that and say it with me. Linear model. Now that word linear refers to a line, so you see me drawing my imaginary line. One of the most common strategies of the linear model that we use in 4th grade is the number line. So you may see me use a number line in this lesson or you may not. But anyway, our strategy that we will definitely use is the 2-column table that we used last time. So let's talk about the key idea. The key idea says use your understanding of measurement. And last week we went through lots of different sizes of these units so that we can have a clear understanding of how big or how small these units are. So in this lesson, we're going to use our understanding of these measurements and the equivalent relationships between the units. You have to refer back to your reference sheet in order to understand the equivalent relationships between the units. So we're going to use our understanding of the measurement and the equivalent relationships between the units of measure to solve the problems. All right, let's start by reviewing last week's practice problem. So you guys were converting 2 hours to seconds. Now we know that 2 hours is equivalent to 120 minutes, but then you need to take those 120 minutes and convert those into seconds. And then you would have converted your 2 hours, and 120 minutes is equivalent to 7,200 seconds. Therefore, 2 hours is equivalent to 7,200 seconds. I will write that nice and large on the board. 7,200 seconds is your answer. Okay? Did you get it right? Of course you did, because you work hard. What strategy did you use? Because you had to take 120 multiplied by 60. Did you use the area model, standard algorithm? Did you use partial product? Or maybe you know how to use the lattice. All right, interesting. Let's go ahead and move into our lesson for today. So I'm going to read the word problem for today's lesson. Again, we are solving problems involving measurement, and the standard is MD 1.2. I'm going to read it, and then when I say number words, as I'm reading it, just to get an understanding, I will use the word sum. So S-O-M-E. And it just helps me to focus on what I'm reading rather than the numbers that are the math that's a part of this. So here we go. It says, Peter is making chocolate pudding. He needs some pints of cold milk per package. How many packages of pudding did he make if he used some quarts of milk? So here I have my 2 units. I need pints, but I'm using quarts. And I want to know how many packages of pudding did I make if I used the quarts. Now the packages are in pints, but I used quarts. Sounds like a conversion problem to me. I'm gonna have to convert these quarts to pints. Now I'm gonna go back and read this word problem and plug in my numbers because I need to know exactly how many quarts do you have here, Peter? All right, here we go. Peter is making chocolate pudding. He needs 1.5 pints of cold milk per package. So these packages that he's using, he needs 1.5 pints of cold milk. Okay, let's see. How many packages of pudding did he make if he used 3 quarts? So now I need to find out what exactly is 3 quarts in pints. Let's take a look at our handy dandy tool, our reference sheet. So when you're talking about quarts and pints, 1 quart is equivalent to 2 pints. Let's note this in our 2-column table. So we are going to go from the larger unit of quarts, and we are going to match the equivalent size in pints. So if we're just looking at 1 quart, we know that 1 quart is equivalent to 2 pints. And if we throw in another quart, and now we have 2 quarts, we know that we will now have 4 pints, and we can go back and revisit our rule. When going from quarts to pint, the rule is to multiply by 2. So if I have 3 quarts, then that equivalency in pints, 3 times 2 equals 6. So 3 quarts is equivalent to 6 pints. So let's go back and take a look at the word problem. So Peter is making chocolate pudding. He needs 1.5 pints of cold milk per package. I'm just going to leave this here. How many packages of pudding did he make if he used 3 quarts, aka 6 pints? So we're going to go ahead and use a part to whole thinking map. So, and we're going to evenly disperse this 6 pints into packages, each holding 1.5 pint. So, go ahead and draw your part to whole map, also known as the brace map. So we have 6 pints. That's what the 3 quarts is equivalent to. And Peter has packages that can only hold 1.5 pint. Well, if I was to take 6 pints and evenly distribute it into packages that can only hold 1.5 pint, let's see how many packages I could use to distribute that. So, so I take 1.5 of the 6 pints, and then I'll take another 1.5 of the 6 pints. So far, how much of my 6 pints am I using in these 2 packages? This is a package, that's a package. So I can take these 2 whole numbers and combine them. 1 and 1 is 2. And if I take the 2 halves and put them back together, I'll make a whole. Kind of like how you take half of an apple and another half of an apple and you combine it and you get 1 whole apple. So the halves equal 1. So I have 1, 2, 3. So with 2 packages, I've already used 3 of my 6 pints. Well, let's see what I can do with the rest of those pints. So throw in another 1.5. I'll throw another 1.5 pints of milk, which is 1 more package. And now I have 4.5 pints of milk. Remember, I had 6 pints to distribute here. So I'll do 1 more package. Now I have 4 packages. That's 3 pints of milk here, 3 pints of milk here, each coming together to make my 6 pints. So let's go back to the word problem. It says, how many packages of pudding did he make if he used 3 quarts of milk? Well, if he used 3 quarts of milk, that's the same as using 6 pints of milk. And you can take 6 pints and you can distribute it among 4 packages if each one of those packages can only hold 1.5 pint of milk. So what's the answer? How many packages of pudding did he make if he used 3 quarts? Peter, how many packages do you see here? 4. Peter used 4 packages. Peter made, sorry, not used. Peter made 4 packages. All right, so I am out of time today. I do want to go over the next problem with you guys, give you guys something to work on in your spare time. So here's your next problem, and we're gonna go over it in the next video on Thursday. So it reads, Louisa bought 3 packages of hamburger meat. 2 packages weighed 2 pounds, 9 ounces each, and the third weighed 1 pound, 10 ounces. How many ounces of hamburger meat did Louisa buy? So here you're looking at ounces and pounds, and we want to take a look at our reference sheet really quickly. 1 pound is equivalent to 16 ounces. So go ahead and convert this, and I'll see you guys next time. Thank you for tuning in with me. Stay fabulous.